Let's talk about how your specific or adaptive immune system deals with invaders, okay? So, we have antigens. Antigens are the bad guys. These might be chickenpox or polio or herpes or hepatitis or Rona. Could be Rona, might be the coronavirus. Okay, so antigens, bad guys, get into your body. APCs gobble them up. Remember, APCs can be dendritic cells, macrophages, or B cells. So what do? They gobble them up, and then they use their MHC2 protein to display the epitope of the antigen. The epitope is the part of the antigen that the immune system can recognize, okay? Then the APC goes and shows that epitope to a T helper cell, also called a CD4 cell, cluster of differentiation marker number 4, all right? So then what happens next? Well, I think we know. What happens next is there's activation here, all right? So activation. Activation. So you see, the T helper cell's job is now to activate the entire remainder of the specific immune system. Because bad guys are here. They somehow made their way inside the walls of the castle. They're here. The Ostrogoths, the Visigoths, the Huns, the Mongol hordes. They're here. So the T helper cell is going to be the one in response to that particular epitope. It's going to now activate the remainder of the specific immune system. So let's look at this side first. It's going to activate here using interleukins, ILs, all right? Interleukins are the little interleukin between leukocytes. Those are the little proteins that communicate between white blood cells. So over here we have the cellular or cell-mediated division of the specific immune system. So the T helper cell will first activate a CD8 cell, which is a T cell, all right? And then what the T cell is going to do, it's going to start cloning itself. It's going to clone itself into T memory cells, and it's going to clone itself into T regulatory or suppressor cells, and then it's going to clone itself into cytotoxic T cells. So in this case, everything that's happening here, this is cloning, all right? These are clones. Remember, this particular T cell responds to whatever this particular bad guy was. If this is measles, this is a measles CD8 cell. If this was herpes, this is a herpes CD8 cell. So it's now going to make clones of itself. Some of these clones, memory cells, will remember that we've been invaded by this particular bad guy. Remember, most white blood cells live only a matter of days or weeks. Memory cells may live for years. And so what happens is, the first time we get invaded, we have to activate the whole immune system and fight it off. But the second time we get invaded, and the 49th time, and the 276th time, and the 74,938th time, the T memory cells will spring into action immediately, and they will clobber that antigen before it has a chance to even get a foothold, all right? Having memory cells is why we say we have immunity. It means that once you get sick with this particular antigen, you'll never have to get sick with it again, because the memory cells will prevent it from ever getting a foothold in your body ever again. The T regulatory cells, some sources call them T suppressor cells. I think the book we're using right now calls them regulatory, so I put R. Could be S for suppressor. Well, one of the things we want to make sure is that the T cells are killers, and we don't want them to overkill. We don't want them to go rogue and start killing good guys. So the T regulatory cells are designed to try to keep the immune system under control. We don't want any bad cops out there, right? We don't want any military going rogue, okay? So we try to make sure that we have a measured response to the antigen. And then the cytotoxic T cells, these are the ones who are the killer cells. So what do? As they wander through the body, they're going to bump into other body cells, all right? So if they bump into an infected cell, every time they bump into a cell, they are going to read the MHC1 protein on that cell. Now notice this cell is infected, so when the cytotoxic T cell reads the MHC1 and sees the epitope of an antigen, what does it do? Kills. Kill. 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 It's going to kill that cell. Because if a cell of your body has been infected, that's like if you get bitten by a zombie. If you get bitten by a zombie, you're going to turn into a zombie. Therefore, you have to be killed. Your friends and your family will hopefully do it for you in a relatively easy way. So yes, if a cell of your body is infected, it has to die. We have to kill it. On the other hand, what happens if a cytotoxic T cell sees a healthy cell? So here is a cell, again it's going to read its MHC1, and it's just got a normal cell product, protein, on the MHC1. In this case, the cytotoxic T cell is just going to say like, hi, I love your shoes. See, it's just going to be, oh look, that's such a lovely floral print. I love it. It's just so bold and fresh. You look fabulous, girl. So that's what the cytotoxic T cell will do in that case. All right, so we got it. Once again, just quick review. Antigens get into your body. APCs eat them. APCs either dendritic cells, B cells, macrophages. Display the epitope on the MHC2. That activates the T helper cell. All right, when they bump into each other, that causes activation. Then the T helper cell starts secreting interleukins. They, in turn, activate a CD8 cell. The CD8 cell starts cloning itself. And by the way, the cytotoxic T cell, it makes lots of these. Because these are the killers. This is the one you want to have lots and lots and lots of in the body. So they are actively killing infected cells, okay? All right, so let's take a look then. What happens? We also have humoral immunity, all right? So humoral immunity, this is antibody mediated. So once again, what we're going to do is the helper T cell is going to be secreting interleukins, and they are going to go and activate a B cell, humoral or antibody mediated, as opposed to cellular cell mediated. So here you have B cells. These are the receptors on the B cells, and notice these receptors are for the same antigen. B cells, remember, can be APCs. So B cells can also grab antigens. They'll do receptor-mediated endocytosis. They will likewise take those in. But when activated by a T helper cell, again, the B cell likewise does a lot of cloning. So it's going to clone itself into these other types of B cells. Okay? And this kind of B cell is going to make lots of these, right? Because these B cells, remember, are APCs. Plus, they can kill bad guys. So we want to have lots of these guys out in the body. So we will clone tons of these guys. So again, this is cloning right here. This B cell is cloning itself into all of these other types of B cells. So it makes a lot more of itself, because those are really helpful. Then it makes B memory cells, so that once again, if this antigen ever shows up again, we remember that we dealt with it before and we clobber it before it has a chance to get going. And then B cells also morph into plasma cells. Plasma cells are the ones that make antibodies. And the antibodies are exactly the same as the receptors on the B cell. Remember, this is the specific immune system. These antibodies aren't just for anything. They're only for what the original antigen was, all right? So we make tons of these antibodies. And remember, antibodies don't actually kill. They just handcuff the bad guys. They handcuff them so that we can then have things like the innate immune system, right? The innate immune system, neutrophils, eosinophils, basophils, natural killer cells, what are they going to do? They're going to come over here and find anything that's handcuffed to an antibody. And what are they going to do to anything they find handcuffed to an antibody? They're going to kill it, all right? Kill. Kill. All right? So there we go. These are the two divisions of your specific immune system. This is so cool, actually. It's just so awesome the way your body works. And this isn't really hard to comprehend. Two divisions. Cell, because we're killing infected cells. Antibodies, because we're making antibodies. See how easy that is? Humeral refers to fluid because the antibodies are floating through the fluids of your body. Okay? So again, B cells, CD8 cells, clone themselves. We get memory cells in both cases. We get lots of cytotoxic T cells and lots of B cells because they're the ones that can directly respond to the antigen. We get plasma cells that make the antibodies. And then we also get these regulatory cells or suppressor cells to try to make sure that we have a measured response and the immune system doesn't go wonky and do more damage than it does good, okay? That's what we're seeing. Now in coronavirus, these interleukins are one type of molecule. They're an example of a category, a class of molecules called cytokines. And one of the things that's happening in the coronavirus, the current pandemic, is the immune system is overreacting and we're ending up with what's called Cytokine Storm. And I talked about that in one of the PowerPoints that I said you should watch, all right? So look for that. You can see the Cytokine Storm. The immune system goes wonky and ends up doing more damage than it does good. A lot of the people who are in the ICUs for coronavirus, for COVID-19, they're getting drugs that are actually immunosuppressant drugs. They're drugs that are trying to suppress, in particular, they try to suppress interleukins and some of the other cytokines. They're trying to stop the cytokine storm because the immune system is going wonky and overreacting, okay? So here you go. This is the specific immune system. I probably should have written that up there, shouldn't I? So this is the specific or adaptive immune system. So specific / adaptive immune system. And remember, it's called specific because it responds to one particular antigen, and it's called adaptive because the T and the B cells weren't ready to go when you were born. They had to go get trained in the red bone marrow or in the thymus. Okay? So text or email me with questions.